All right, so we had left off with these practice problems on page 85, okay? And we did practice problem number 1 in both portions of that where we're making that conversion of a mass to moles or a mole to a mass. Is it worth your time to do more examples, or are we comfortable with that? More examples. All right. Page 85, up on top, it says, what is the mass in grams of 0.375 mole of the element potassium? Okay. Okay. More tables. Have this memorized. Nah, you won't have it memorized. Oh, why, thank you. Oh, I think you'll have a lot of it memorized, probably by just utilizing it a lot. Oh, you know more than that. Yeah. Okay, so with that problem, I just happen to look. Now that we've checked our phones, I'm sorry. I was just looking up, and I was just seeing people are maybe checking their phones for the last time before they put it away. And, yeah. Anyway, how do we start? Practice problem number 2 on page 85. We're talking about potassium. What about that number, 0.375? What about it? Okay, so 0.375 mole, and then please do this for yourself. It makes this a lot easier for yourself, and if you're having problems with it, it helps me help you as well. Okay, so how do we cancel out this mole in step 2? Because this is step 1. Okay, so for every mole of potassium, and notice it's asking for what is the mass in grams. So we don't make that number up. Where do we get the number for the mass in grams? Atomic mass found on your table. So look at element number 19, and see, that's what I mean. That's how you're going to memorize that. What is potassium's atomic mass? Okay, we don't just make that number up. It comes off the periodic table. It's asking for what is the mass in grams. We're in grams now in step 2, so that's all the further that we need to go. So with that, you should get approximately 14.7 grams by multiplying those two numbers.
How do we know which quadrant to put those numbers in?
Okay. When we start with this, since it's on top, you need to cancel that out in this molar mass, okay? Okay, grams per mole is a molar mass, so is moles per gram, depending upon which one you're starting with. To cancel it out, that tells you which one to put it on the bottom. Because if we put moles of potassium on top, we're multiplying by moles, that gives you moles squared. We don't want that. Nearest hundredth, 2 decimal places. Okay, are problems? Or?
No, I'm
well, it didn't look like that. Okay. Oh. It is. It's a counting unit. Okay. It's measuring. We haven't quite learned. We don't want to go that far in depth. It's telling you how much of a substance is in a compound. Hence, a counting unit. So what that means is, like for instance on what will be handed out today, like KOH here, for instance, this is a little ways down the road, but with this, like for instance in this problem, what this allows us to do is calculate how much of that substance is potassium. But again, if we go that far in depth, we're talking about that is in October, somewhere around there. Early to mid-October, we'll start talking about molar mass problems. So this is just a counting unit, and it's setting the stage up for being able to calculate how much of maybe potassium is within this compound of potassium hydroxide. It's just a counting unit that allows you to see how much of that is a pure substance. That's the best way that I can try to explain that, and maybe that did or did not help. If I was a betting person, I would say that did not help. Okay?
I'm just not gonna ask questions.
Well, that's why we're here. Now this is based off of dimensional analysis. Did you see the quarters example? Okay? We're not just nodding our head, yes, we did.
Yeah,
You saw that. Were you here for that or you watched it?
watched it like
Okay.
10 minutes ago.
Oh, okay. So with that, more examples? Do you want to do another practice problem? Or else maybe you want to try number 3 on your own and see if you get 0.31 approximately. That will tell us how well you may or may not understand this content.
Practice at the top or the bottom of the page?
Top. Okay. Saying what is the mass in grams of 0.0135 moles of the element sodium. Let's go ahead and take a peek at that one. And it's just a repeating pattern that hopefully once we catch on to that, you'll look back and this and say, okay, this wasn't so bad. And that's our goal, because that way that tells us that you are learning and comprehending this material. Can we say that we've got 0.31? Okay. We good? Okay. Better than we were 30 seconds ago.
No, I understood how to do it. I just did not know what a mole was.
Oh, okay. All right.
0.31.
0.31, yes. Okay. Mix it up a little bit, go over the problem or examples of the problems on the bottom, or do we need or want to look at number 4? Asking for input. Okay, on the bottom. Okay, so one of the things you just need to be aware of and see where it is that you're starting in step 1 to tell you where you're going in step 2. So practice problem number 2 on the bottom, page 85 in the practice section. Okay? How many moles of gold, Au, are in 3.60 times 10 to the negative 5th grams of gold? Okay? There's 2 different ways you can approach this problem. You can just use a whole number right away, or you can utilize the scientific notation. Do you want to see both ways? You want to see the scientific notation. All right. So we've got, again, 3.60 times 10 to the negative 5th. Okay, so 3.60 times 10 to the negative 5th. Again, this is mole of Au. This is step 1. So in our molar mass, how do we get rid of this mole or counting unit in step 2? We put it on the bottom. For every mole, okay, of,
I thought we were finding moles.
we are. I was just seeing if anybody was paying attention. Okay? So how do we cancel that gram in the next step? Okay? So for every gram of Au, you receive a mole of Au. All right? And that's why when you write this factor label method down, you can look at it and say, well, this doesn't seem right. That's why I paused for a little, or maybe you could say we paused for a little bit, say that just isn't right. So here we need to know what is the mass of gold. 179? 196. Point, or is it round up to 197? Okay, so 197. Yep, we round all them up. Okay. And if you wanted to, you could put the 2 decimal places here, because we're rounding up to the nearest hundredth. Depending upon what it is that you're starting with. You're always and only just a mole. Okay? Now, a long way down the road, okay, how many of you remember balancing chemical reactions? Okay? That you'll be utilizing here early next semester. So if you can't balance chemical reactions, it hopefully something we can improve upon to get better at, and we'll be just fine. All right, so is anyone having problems punching these into your calculator? Okay, otherwise this is how we do it. Okay, go ahead and punch in 3.60. Hit your second function, this blue button, upper left-hand corner. Okay, then look for where it says x to the minus 1, but since you hit the second function, you're changing that to where it says EE. Once you hit that, you'll see an exponent pop up, or letter E. That's telling you you're in scientific notation now, so then you just hit -5, okay? And then you're dividing that by 197. And the author says we are supposed to get 1.83 times 10 to the -7th, but I bet you it doesn't tell you that here. It just gives you a number that's in a decimal format, right? Okay, so what that means then, okay, so we've got 1, 2, 3, 4, 5, 6. Okay. Now that is moles of gold. Mole AU. But if we were to convert that to scientific notation, this is what the author says: 1.83 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. There we go. So left side, are we on the bus here? And maybe we don't know. Are we good on left side here? Left side? Yep, yep. Left side, left side, left side. Oh, okay, fair enough. Middle. We're just after dinner, so we're feeling a little sluggish, so it's hot out. Flies are being pestering, yeah. So right side. Okay? All right. Yes? Dang it. Keep getting an error on that. Okay. So chances are we're punching the same function twice, or a number twice. Okay? So go ahead and we don't need the parentheses on there. Okay?
Oh yeah, we tried it without the pencil.
Okay, so punch in 3.60. Okay, hit this upper left-hand corner, that one. Now hit -5. negative down there. Okay, now divide that by 197. There you go.
But I did the same thing.
Okay.
Right, so then how we do number 3 in the bottom?
Okay.
That one doesn't have the.
It doesn't. Number 3 is actually a little simpler. Okay. The question was, for number 3, how many moles of zinc are in 0.535 grams of zinc? Can we close the books on this one? Okay. So 0.535 mole. There, I did it again. Grams of zinc. Okay. So how do we cancel grams out in our next step? Upstairs or downstairs? Okay, we're going to put grams of zinc down here. Okay. And then what do we put on top? Okay. And then the atomic mass of zinc, 65.38. Okay. The example we did last week, I've always used sulfur, but in this case, if we've got this cup here, if we put 65.38 grams of ground up zinc in here, we have exactly one what? 1 mole. Every time that you get a mass that is equal to what you have on the periodic table, whichever element it is, 32 for approximately 32 for sulfur, 65 for zinc. You could say 10.81 grams for boron. When you equal that out, that is 1 mole of that substance. But we're not starting with 1 mole, okay? So with that, what we see happening, you're going to divide by this, and you're going to get a really, really small number. 8.18 or 0.00818. That sound right? Okay. So what that means is you either had this on your calculator or 0.001, 818. Okay. Any questions on this scientific notation? It takes a little bit to catch on because you haven't been taught this before. This is brand new material. Just think of maybe 2 years ago when you had to look at this guy. Remember all that good stuff? That was maybe difficult too, but you've never learned that before. So the first time you see it, it may appear to be just a little difficult. But that's why when we said welcome to junior year, one of the things that we want you to keep in mind on the ends, it's a little different, but here in the middle, if you get stuck, look to your left, look to your right. There might be someone there that can help you. Obviously over here, you got to look to the right. Over here, you got to look to the left. Unless we're not saying your whether it's your lab partner or table partner, yes, they can help you there too. Do you like this setup better, these tables, as opposed to the desks?
The chairs are a little low on the table.
Tiny. My knees.
Yes.
They're only like 6-foot chairs.
It always has to be competition.
Yeah.
Okay.
Kind of that mentality.
Like, who gave us the kindergarten chairs?
I don't know. Okay.
I think that their feet would even touch the ground.
Especially when it comes to video games.
Can we close the books on this? All right. So for what you can do now, you need your table. and your calculator, you have about 20 some minutes. I don't know how much time you'll be given in class tomorrow, so I would highly suggest you work on these. You don't have to get it all done. It's not due tomorrow. It says the 25th. Okay? Sure. It just says, write the correct AMU, atomic mass units or grams, for the following compounds. All you're doing is just adding together the atomic masses. You might think, well, all we're doing is adding. How difficult can that be? Well, for some people, it's easy to make mistakes. But what do we talk about mistakes? Two things. What about mistakes? Okay, first of all, try not to repeat them, and then learn from them. All I heard was outside. Oh, in the hallway? Yeah, perhaps. See, do you like that table? Okay. I just looked over there. I don't know, maybe I'm one short. I will get you another copy. All right, that's all I have. We'll catch up to you next time.